All right, this is Unit 7, Lesson 3, Trigonometric Functions and Real Numbers. So our lesson essential question is, how is the unit circle related to trigonometric functions? And at the end of this lesson, you'll be able to use the unit circle to evaluate the trigonometric functions of any angle. Example 1, use reference triangles to evaluate sine and cosine. What are the sine and cosine of the angle 2 pi over 3?
What are the sine and cosine of the angle 2 pi divided by 3? You can solve this problem by creating a reference triangle. Draw a vertical line to connect the terminal side of the axis to the x-axis. Your triangle includes the angle that is supplementary to 2 pi divided by 3, which is pi minus 2 pi divided by 3, or pi divided by 3. Since cosine of pi divided by 3 gives the length of the bottom side of the triangle, and sine of pi divided by 3 gives the height of the triangle, the coordinates of the terminal point of the reference triangle are cosine of pi divided by 3, sine of pi divided by 3. Calculating those values gives the coordinates 1/2 and square root of 3 divided by 2. The reference triangle and the triangle with the reference angle in standard position are congruent, so the side lengths of the triangles are the same. This means that the values of sine and cosine are correct. However, the signs of these values need to be determined. Since the terminal point of 2 pi divided by 3 lies in quadrant 2, the value of cosine is negative, and the value of sine is positive. The cosine of 2 pi divided by 3 is negative 1/2. The sine of 2 pi divided by 3 is square root of 3 divided by 2. What are the sine and cosine of a negative 45-degree angle? A reference triangle for a negative 45-degree angle contains a 45-degree angle. That means that the coordinates of the terminal point of that angle are square root of 2 divided by 2, square root of 2 divided by 2. Once again, the correct values have been found, but the signs of the values need to be determined. The negative 45-degree angle is in quadrant 4, so the cosine is positive and the sine is negative. The cosine of negative 45 degrees is square root of 2 divided by 2. The sine of negative 45 degrees is negative square root of 2 divided by 2.
All right, so let's try it. What are the sine and cosine of each angle? 4 pi over 3. So 4 pi over 3 is going to be, it's really the same thing as 3 over 3 times pi over 3, which is really like 1 pi over 3. So if I subtract pi from both sides, I'm left with pi over 3. This is what I'm looking for. This is my reference angle. So this pi over 3 is related to the 4 pi over 3 because I subtracted pi from both sides from it to figure out what my reference angles were. So then I have cosine of pi over 3 and then sine of pi over 3. Okay. This equals square root of 3 over 2. And, oops, sorry, this is 1/2. And then square root of 3 over 2. But I need to figure out what the signs are, whether they're positive or negative. So 4 pi over 3 is going to be in my third quadrant. So that means both of my answers are going to be negative. So cosine of 4 pi over 3 equals negative 1/2. And sine of 4 pi over 3 equals negative square root of 3 over 2. For B, 3 pi over 4. So this is 3/4 of pi. So 3/4 is 3/4 of the way between 0 and pi, which means it's going to be in the second quadrant. So my sine of 3 pi over 4 equals the square root of 2 over 2. So that's my y value, and my cosine of 3 pi over 4, equals negative square root of 2 over 2. So this will actually be a 45-degree angle, which is where we're going to get the square root of 2 over square root of 2 over 2 and square root of 2 over 2 for sine and cosine. Remember, your cosine is your x value and your sine is your y value. All right, example 2, use the Pythagorean identity sine squared theta plus cosine squared theta equals 1. What is sine theta if cosine theta equals negative 3/5 and the angle with measure of theta is in quadrant 3? So I want to sketch the angle with measure theta and its reference triangle on the unit circle as shown. Okay. The coordinates of the points where the terminal side of the angle intersects the unit circle are cosine theta, sine theta. The reference triangle has side length of absolute value of cosine theta and the absolute value of sine theta. Cosine theta, sine theta. Note the absolute value signs. The coordinates sine theta and cosine theta might be positive or negative, but the lengths of the sides of the triangle are always positive. A hypotenuse of the reference triangle has a length of 1 because we're in the unit circle and all hypotenuses, because it has a radius of 1, so any hypotenuse of a triangle, a right triangle, is going to have a hypotenuse of 1. The length of the side of the triangle opposite theta is sine theta. The length of the side of the triangle adjacent to theta is cosine theta, or in this case, the absolute value of negative 3 over 5, or 3/5. So relate these values to those used in the Pythagorean theorem to find the third side of the triangle. This will give you the y-coordinate of the terminal point, or sine theta. So sine squared theta plus cosine squared theta equals 1. This is called the Pythagorean identity. Given cosine theta equals negative 3/5, you can solve for sine theta. So sine squared theta plus cosine squared theta equals 1. I substitute in negative 3/5 for cosine theta. So I have sine squared theta plus negative 3/5 squared equals 1. 3/5 squared is 9/25. I subtract that from both sides. I have sine squared theta equals 16 over 25. And I square root both sides. So I'm left with sine theta equals plus or minus 4/5. Since the angle is in quadrant 3, the y-coordinate sine theta must be negative. Therefore, sine theta equals negative 4/5. All right, let's try it. What is sine theta if cosine theta equals the square root of 2 over 2 and 0, and theta is between 0 and pi over 2? Okay, so sine square root of 2 tells me that cosine theta equals square root of 2 over 2, tells me that sine theta is also square root of 2 over 2, because this is going to be a 45, 45, 90-degree triangle. Okay, this is something that the more you practice with this, the more you just kind of recognize some of these identities right off of the bat. But we're going to go ahead and solve just like we would using the Pythagorean identity. So I have sine squared theta plus cosine squared theta equals 1. We don't know what sine squared theta is, but we do know what cosine is. And cosine theta is square root of 2 over 2. So we're going to do square root of 2 over 2 squared equals 1. Square root of 2 squared is square root of 2 times square root of 2, which is just 2. So sine squared theta plus 2 over 4, which is 1/2, equals 1. So sine squared theta plus 1/2 equals 1. I subtract 1/2 from both sides, so I get sine squared theta equals 1/2. I'm going to take the square root of both sides. Okay, so this gives me sine theta equals the square root of 1 over the square root of 2. Well, the square root of 1 is just 1. I need to multiply both sides by the square root of 2. So 1 over the square root of 2 times the square root of 2 over the square root of 2. Really, all I'm doing here is I'm multiplying by 1. I'm just getting that square root out of the denominator, which we don't like them in the denominator. It's just not great. Okay, so when I do that, I get the square root of 2 over 2. So if you didn't know that sine theta is square root of 2 over 2 and cosine theta is square root of 2 over 2, you can still use the Pythagorean identity and get the same answer. Okay, so for B, what is cosine theta if sine theta equals negative 0.8 and theta is in quadrant 4? Okay, so I'm going to ignore that theta is in quadrant 4 for right this second. I'm going to set up my Pythagorean identity. We know that sine theta is negative 0.8, so negative 0.8 squared plus cosine squared theta equals 1. 0.8, negative 0.8 squared is 0.64. Oops. Cosine squared theta equals 1. I'm going to subtract 0.64 from both sides. So 1 minus 0.64 gives me 0.36. So cosine squared theta equals 0.36. I'm going to square root both sides. 6. Okay. So the square root of 0.36 is 0.6. So cosine theta equals either positive or negative 0.6. The square root of 2 over the square root of 2 is also could have been positive or negative. We just knew it was positive because we were dealing in quadrant 2, because it was between 0, or we're dealing in quadrant 1 because this is between 0 and pi over 2. This one we know is in quadrant 4. We remember that cosine is my x value, and in quadrant 4, my x values are positive. So cosine theta is going to be positive 0.6. Example 3, use the unit circle to evaluate tangents. So what is tangent of negative 5 pi over 6? To find the tangent of negative 5 pi over 6, start by finding the sine of negative 5 pi over 6 and cosine of negative 5 pi over 6. Then use the identity tangent theta equals sine theta over cosine theta to find tangent of negative 5 pi over 6. Sketch the angle and its reference angle triangle on the unit circle as shown. To find the values of tangent negative 5 pi over 6 and cosine negative 5 pi over 6. The angle with measure negative 5 pi over 6 is in quadrant 3. Its reference angle is pi over 6, or 30 degrees. The reference triangle is a 30, 60, 90 degree triangle. The length of the hypotenuse is 1. The length of the shorter leg is 1/2. And the length of the longer leg is the square root of 3 over 2. By considering the signs of a point in quadrant 3, you can determine that the coordinate of the point where the terminal side of the angle meets the unit circle is negative square root of 3 over 2 and negative 1/2. Use the reciprocal identity for tangent. Tangent of negative 5 pi over 6 equals sine of negative 5 pi over 6 divided by the cosine of negative 5 pi over 6. So it's negative 1/2 divided by negative the square root of 3 over 2, which gives us the square root of 3 over 3. So the tangent of negative 5 pi over 6 is the square root of 3 over 3. What is tangent of 3 pi? 3 pi equals 2 pi plus pi. So 3 pi is coterminal with pi. The terminal point of pi has coordinates negative 1, 0. since tangent of theta equals sine theta over cosine theta, tangent of theta equals y over x. From this, you can conclude that tangent of 3 pi equals 0 over -1, or 0. All right, let's try it. What is the tangent of each angle? For A, I have -3 pi over 2. The tangent of 3 pi over 2, okay, so when I actually draw this on my unit circle, this is going to give me the y-axis, which gives me the points 0, -1. So cosine equals 0, sine equals -1. Tangent theta, tangent of -3 pi over 2 is going to give me tangent is opposite over adjacent, which is y over x, which would give me -1 over 0. This means that tangent of -3 pi over 2 is undefined because I can't divide by 0. Okay, then I have 675 degrees. So I want to figure out where that would actually be on my unit circle. So I'm going to do 675. I know that there's 360 degrees in a circle, so 360 gives me 315. So 315 degrees is equal to 7 pi over 4, which is in quadrant 4. So that means cosine of theta equals the square root of 2 over 2, and sine theta equals negative square root of 2 over 2. Remember, cosine is your x, sine is your y. So tangent of 675 equals y over x, or my sine over my cosine. So that gives me negative square root 2 over 2 divided by square root of 2 over 2. So that's opposite. So it's 2 over the square root of 2. When I multiply, this is going to give me -1. Example 4, evaluate the reciprocal functions. Evaluate the secant, cosecant, and cotangent of a 135-degree angle. So the coordinates of the terminal point on the unit circle are negative square root of 2 over 2 and square root of 2 over 2. So for a 135-degree angle, it gives me a 45-degree angle from the 180 degrees. So that's where I got these functions from. So the secant of theta equals 1 over the cosine of theta. So secant of 135 equals 1 over the square root of 2 over 2, and it's negative. Remember, I keep, change, flip. So I keep my first, I change my division to a multiplication, and I flip my second number. So square root of 2 over 2 becomes 2 over the square root of 2 multiplied by 1. I still have that negative sign. Then I'm going to simplify it because I don't like radicals in my denominator. So I multiply both of these by the square root of 2 over 2, which gives me negative square root of 2 over 2. I had that 2 up front, so they canceled. So I was left with negative square root of 2. Okay. For cosecant, theta equals 1 over sine theta. So cosecant of 135 degrees equals 1 over square root of 2 over 2, which equals the square root of 2. And then cotangent equals 1 over tangent theta. So cotangent of 135 equals 1 over -1, and that equals -1. We found the tangent by taking the sine divided by the cosine. All right, so let's try it. What are the secant, cosecant, and cotangent for each angle? The first one I have is 210 degrees. Well, 210 degrees is the same thing as 7 pi over 6, which means sine theta equals negative 1/2, and cosine theta equals negative square root of 3 over 2. And I'm going to go ahead and find tangent of theta just so I can know that. That's going to be negative. So tangent theta is negative 1/2 over the square root of 3 over 2, which gives me negative 1/2 times 2 over the square root of 3. I copied it down wrong, so I want to make sure I have it right. So negative 1/2 times that will give me 1 over the square root of 3. Again, I need to multiply both sides by the square root of 3 over the square root of 3, which gives me the square root of 3 over 3. Okay. So then I'm going to find the secant, cosecant, and cotangent for this. So the secant of 210 equals 1 over, and the secant is the opposite of cosine, so cosine theta. So this is going to be 1 over square root of negative 3 over 2. Gives me 1 times negative 2 over the square root of 3. So that gives me negative 2 over the square root of 3. Again, I want to multiply both sides by the square root of 3 over the square root of 3 to get that square root out. So I have negative 2 square root 3 over 3. So that's for my secant. My cosecant of 210 equals 1 over sine theta. So that's 1 over negative 1/2. So that's 1 times negative 2, which gives me negative 2. My cotangent is 1 over the square root of 3 over 3 equals 1 times 3 over the square root of 3. Okay, so when I do this, I get 3 over the square root of 3. I then need to multiply both the numerator and the denominator by the square root of 3 in order to get the radical out. So I have 3 square root of 3 over 3, which simplifies to the square root of 3. Okay, for B, I have negative 10 pi over 4. All right, so negative 10 pi over 4. So negative 10 pi over 4. I want to add 2 pi to this to see. I want to add 2 pi to figure out what the coterminal angle is. So negative 10 fourths plus 2 is negative 1/2. Negative pi over 2, or negative 1/2 pi. Okay, so that's going to give me the 200. It's the same thing as the y-axis, which would give me, remember I'm going this way because it's negative. Okay, so I'm going clockwise as opposed to counterclockwise if it were a positive. Okay, so negative pi over 2 is the same thing as saying sine of theta is negative 1, cosine theta, sine theta equals negative 1, cosine theta equals 0, tangent theta is going to be 1 over 0, which is undefined. So for secant of negative 10 pi over 4, that's going to be 1 over cosine theta. which equals 1 over 0, which is undefined. The cosecant of negative 10 pi over 4 equals 1 over sine theta, which is 1 over negative 1, which will give me negative 1. And then cotangent of negative 10 pi over 4 equals 1 over tangent theta. And tangent theta is 1 over 0, which is like saying 1 times 0 over 1, which is 1 times 0, which is 0. Example 5, use any circle centered at the origin. A group of rescue teams are searching a circular area in a 4-mile radius around their camp. One team travels on a path 30 degrees east of south from the camp. What is their final position relative to their camp? So formulate. Draw a circle with a radius of 4 to represent the search perimeter, with the camp as the origin. Show the path of the team by drawing a radius at 30 degrees east of due south. So here, when you're dealing with a radius, I have north, east, south, west. So east due south. So east of due south. So due south is here, 30 degrees from that. This corresponds to the angle of 270 plus 30, which equals 300 degrees. So the path you have drawn makes a perpendicular line from the team's final position to the x-axis. Create a right triangle with a hypotenuse of 4. This triangular is similar to a triangle on the unit circle. The scale factor between the triangle is 4, since your triangle has hypotenuse 4 and the unit circle triangle has hypotenuse of 1. The team's final position on the search perimeter will have coordinates 4 times those of the terminal point of 300 degrees on the unit circle. On the unit circle, the terminal point of 300 degrees is 1/2 and negative square root of 3 over 2. So the team's final position on the search perimeter circle will be at 4 times 1/2 negative square root of 3 over 2. When I multiply 4 times 1/2, I get 2, and 4 times negative square root of 3 over 2 gives me negative 2 square root of 3. So the point 2, negative 2 square root of 3 represents a position that is 2 miles east and about 3.5 miles south of the camp, because negative 2 square root of 3 is about 3.5. All right, so let's try it. What is the final position of a search team relative to the camp if they walk 30 degrees north of due west for 5 miles from their base camp? Okay. So here is my circle that I've drawn. So here's north, east, south, west. Okay. So the problem told me they walk 30 degrees north of due west. So they started west and they walked north. So this is going to be 30 degrees. Okay. They also told me that their search radius was 5 miles from the base camp. Okay, so that was their hypotenuse is going to be 5. Okay. I can draw my triangle. So this is the point that I'm looking for. So this is pi, or 180 degrees. So 180 minus 30 is 150 degrees. So that's the angle that I'm looking for. So that angle, 150, is going to be negative 93 over 2. Okay, so that's the original points if I'm dealing with just the unit circle, which has a hypotenuse of 1. So this is going to be 5 times that. So this is my point. Remember, I did 180, which is here, minus 30, because it was due north. Okay, so this gives me the 150. So this is 150 and 150. Okay, so that's where I got that angle from. So I multiply 5 times negative square root of 3 over 2 and 1/2. Okay, so this gives me negative 5 square root of 3 over 2 and 5/2. When I substitute that into a calculator, because that's square root of 3 divided by 2. So this is going to give me approximately negative 4.33. And 5/2 is 2.5. Okay. So what this is telling me is I went about 4.3 miles west and 2.5 miles north is what this is telling me. So west, north. Okay. Remember, EW, that's on your x-axis, and the north and south are on your y-axis, which is how I know that this is west and that's north. Concept summary: trigonometric functions and the unit circle. A reference triangle is formed using the terminal side of an angle and a perpendicular segment from the terminal point to the x-axis. This can help you find the coordinates of the terminal points on the unit circle. So trigonometric functions on the unit circle, so here's my graph, and really on any circle, okay? For any angle with the measure theta in standard position with terminal point x, comma, y on the unit circle, sine theta equals y, cosine theta equals x, tangent theta equals y over x, cosecant theta equals 1 over y, secant theta equals 1 over x, and cotangent theta equals x over y. For any angle with measured theta in standard position with terminal point x, comma, y on any circle, I have the sine of theta equals y over r, where r is the hypotenuse. Cosine of theta equals x over r. Tangent of theta equals y over x. Cosecant of theta equals r times 1 over y. Secant theta equals r times 1 over x. And cotangent theta equals x over y. And that is the end of Unit 7, Lesson 3.